At the end of this lesson, students should be able to differentiate between amorphous and crystalline solid. Number 2, student can be able to state the following type crystalline solid and give appropriate example. Number 1, metallic. Number 2, ionic. Number 3, molecular covalent. And number 4, giant covalent. Two types of solid, which is crystalline solid and the other one is amorphous solid. So what is the difference between this type of solid? Now we will see the difference between amorphous and crystalline solid. Before that, look at to this diagram. This diagram shows the arrangement of particles in amorphous solid, and this one shows the arrangement of particles in crystalline solid. From this diagram, we can see that the different arrangement of particles in amorphous and crystalline solid. In amorphous, particles are arranged randomly and have no ordered structure, but in crystalline, particles are arranged closely packed and have an ordered structure. Amorphous solid do not have sharp melting point, but crystalline solid have sharp melting point. Amorphous solid is formed from when saturated liquid cool rapidly, but crystalline form when saturated liquid cool slowly. Example for amorphous solid is charcoal, rubber, and glass. And example for crystalline solid is metal, salt, graphite, and diamond. Metallic solid. In metallic solid consists positive ion of atom held together by surrounding sea of electron and strong metallic bond. The melting point of metallic solid is from low to very high, and metallic solid is good conductor of heat and electricity. Example of metallic solid is metal element, which is, for example, sodium, zinc, iron, and etc. Ionic solid. In ionic solid consists of cation and anion that held together by strong ionic bond. Melting point of ionic solid is high, and ionic solid is poor conductor of heat and electricity in solid state, but good conductor of heat and electricity in molten state or in aqueous solution due to free moving ion. Example of ionic solid: NaCl, MgO, CaF2, and etc. Molecular covalent solid. In molecular covalent solid, molecules are held together by intermolecular force, either van der Waals force or hydrogen bond. The strength of intermolecular force depends on polarity of molecules. The melting of molecular covalent solid is from low to moderate, and molecular covalent is poor conductor of heat and electricity. Example for molecular covalent solid is oxygen, C4H10, P4, and etc. Giant covalent solid. In giant covalent solid, atoms are held together by strong covalent bond and form giant network. The melting point of giant covalent solid is very high, and giant covalent solid is poor conductor of heat and electricity. Example for giant covalent solid is diamond, graphite, and SiO2.